This is what we are going to see now. So what is here? The high pass filter. This is the design of the normal high pass filter. So the basic operation of an active high pass filter is same as the RC passive high pass filter, except its design providing amplification and gain control. So if I want to separate the two stages, I can include this voltage follower between two stages, but I want to also have some amplification. Then instead of having this typical buffer or voltage follower, I am going to add some resistor, and then I can control the gain, so I can amplify the signal at the output instead of having the same amplitude. So the same circuit, just modified here a little bit. So this is the passive high pass filter. You know that how to design. So we are in the high pass filter, you are getting the output across the resistor. So you should remember the difference. The low pass filter, you get the output across the capacitor. Okay, this is the high pass filter, and then you have the operational amplifier. Either it can be non-inverting configuration or inverting configuration. That's not a matter. So here we are using non-inverting configuration of the operational amplifier. It means we are applying the input to the non-inverting input terminal, that is a plus. So there will be no phase difference here. So the other terminal, negative terminal, has the negative feedback through a resistor, feedback resistor R3, and we also have another resistor, input resistor, for this terminal. So this is the entire design, the complete design of first order active high pass filter. So this is the first order. Why it's a first order? Because we are having only one pole. If you have more poles, then you can say accordingly the number, second order, third order filters. So like previous active low pass filter, the simplest form of an active high pass filter is to connect a standard inverting or non-inverting operational amplifier to the basic RC high pass filter. That's what we have done here. We are connecting this and this, then it becomes active high pass. So remember the formula of the gain of this non-inverting op amp. So that is 1 plus RF divided by R1. So RF is this R3, R1 is this R2 here in this circuit, according to these notations. So 1 plus R3 divided by R2, that is the gain of this operational amplifier. And what is the cutoff frequency of this high pass filter? That is 1 divided by 2 pi RC. So R and C value is based on this R and C value. So you can change the cutoff frequency by changing the value of C and R. So now what is the gain of the complete this filter? This is the formula. So that is why I asked you to write down in your notebook. So this is the formula for active high pass filter gain. So is equal to AF times F divided by FC divided by square root of 1 plus F divided by FC whole square. So this is the formula you have to remember for active high pass filter. For active low pass filter, we have totally different formula. Here, what is F and FC? The same like the previous one. F is the frequency of the input signal. That is the input signal. And FC is the cutoff frequency of the circuit. So we have this, and then we have the cutoff frequency somewhere here, FC, based on your R and C value. So high pass filter will block the low frequencies, and then it will pass the high frequencies. Okay, so now what else we have for this? Here also 3 cases you can see. Case 1, case 2, case 3. In the case 1, what we are seeing, applied frequency is less than the cutoff frequency. At the time, the gain is less than the AF. So it means you don't get anything at the output at the low frequency, because this is the FC. So you are applying the input signal frequency. For example, this is the low frequency region. So you don't get at the output because the gain is less than AF. When this F is equal to cutoff frequency, the input signal frequency is equal to the cutoff frequency value, then that is the minus 3 dB level you reach. So AF divided by square root of 2, that is a 0.707 AF. So then the signal start to rise up rapidly. And at very high frequency means what? The input signal frequency is more than the cutoff frequency. Then the gain value will go up. The output will start to rise. So this is the 3 dB level, maybe minus 3 dB. This is just approximate drawing. So now here it will increase rapidly and then its output will reach the maximum. This is the high frequency region. So the same cases we can apply in both active low pass and active high pass filters. Yes, active high pass filter, I just explained the same thing here, I think. This is indicating the definition for this first one. Has a gain, we know that AF that increases from 0 Hertz to the low frequency cutoff point. And after that, this 20 dB per decade increases after the cutoff frequency. At FC, the gain is minus 3 dB level. There is a 0.707. Where is the frequency curve? So here you can see we are in the low pass filter. So in the high pass filter is the opposite. Yes. So here you can see the minus 3 dB level. This is the 0.707 times gain. If you assume the gain as a unity gain, then this is equal to V in. Okay, so because we know A is equal to V out divided by V in. So V out is equal to A times V in. If A is 1, then V out is equal to V in multiplied by this standard value 0.707. So we are in the active high pass filter now. Yeah. So that is when the FC is equal to F, then it becomes like this. And then after the FC, when you increase the input frequency more and more higher, then it start to pass the high frequency signals because this is a high pass filter. Okay, I do not want to read this, so please read it. When dealing with filter circuits, the magnitude of the passband gain of the circuit is generally expressed in terms of dB. So that is the voltage gain. So this is the formula, the same standard formula. This one is not changing. So that is why we call this one, the frequency is increasing 20 dB per decade. And for the first order and the second order, it will be more sharp, minus 40 dB. And for third order, it will be minus 60 dB per decade. So it will sharply rise more and more when you increase the order of the filter. And this is the formula for the phase shift. And this is the formula for cutoff frequency of single order active high pass filter. How can you construct the filter circuit? And how can you calculate the output? We have the formula. And how can you calculate the cutoff frequency and the V out or the gain for these both categories of filters, LPF and HPF?